In this video, I'll introduce you guys to covalent and ionic compounds and how we name covalent compounds. So, an ionic compound usually it consists of a metal and a non-metal. An example of an ionic compound would be CaCl2, calcium chloride, or Fe2O3, iron 3 oxide, or SNO. This is called tin 2 oxide. Yeah. So these are examples of ionic compounds because they contain one metal and one non-metal. You learn about ionic compounds you learn about them in detail in chemical bonding. And covalent compounds, they usually consist of a metal. They usually consist of non-metals. For example, CO, carbon monoxide, or So3 sulfur dioxide, CO2, carbon dioxide, PCl5, etc. So in this video, we'll be focusing on how to name such compounds: CO, SO3, CO2, how to name covalent compounds. Covalent compounds are also called molecular compounds. So to name these compounds, all you have to do is follow a simple set of rules, and these are the rules. So first, you have to identify the type of compound. So for example, if I write a covalent compound of P4O10, you first have to identify whether this compound is ionic or covalent in nature. And we can see that phosphorus and oxygen are two non-metals. So this compound is covalent. Okay, so step 1 is done. Step 2 is identify the first element's name. So by first element we mean this element, the element at the start. In this case, the first element was carbon. Here it was sulfur. Here it was phosphorus. So P stands for phosphorus. So we'll write that, phosphorus. Then write the second element's name with IDE. So second element here is oxygen. And what we have to do is we have to replace all of this stuff, YGEN, with IDE. So we have to write oxide. So we get phosphorus oxide. Now step 4. This is the final step. And now we have to use prefixes. So by prefixes, I mean these. These are the prefixes which you have to remember in order to name covalent compounds. Mono stands for 1. Mono, di, tri. So in order to name covalent compounds, you have to remember this list of prefixes. So this list is pretty useful. These prefixes are pretty useful because they tell us the number of atoms of an element in a covalent compound. So di means 2. So if I write dioxide, then that would tell me I have 2 oxygen atoms in this compound. But we can see that we have 10 oxygen atoms. So we're going to write DEKA, deca. This is sometimes also written as deca. In some lists, deca is given as DECA. So we're going to write DECA, deca oxide. And for phosphorus, we have 4 atoms of phosphorus in P4O10. So we're going to use 1, 2, 3, 4 tetra. Now, according to chemists, it's pretty awkward to pronounce deca oxide. They just find it convenient to remove the A and pronounce this as dec oxide. But this is another rule, and we're going to learn this at the end of this video. N2O3. So first we have to identify the type of compound. Nitrogen and oxygen are non-metals, so this is a covalent compound. Then we have to identify the first element's name. In this case, the first element is N, and N stands for nitrogen, so we have to write that down. Nitrogen. Then we have to identify the second element's name, and we have to add IDE. So this O stands for oxygen, and adding IDE would give us oxide. Then we have to use prefixes. We have 2 atoms of nitrogen in N2O3, and 2 corresponds with the prefix di. So we'll write Di, dinitrogen, and we have 3 oxygen atoms. 3 corresponds with dry, so we'll write dry here, and we get dinitrogen trioxide. Another thing which you should remember is that we always write the second element's name with IDE, always. Next is B4S10. So phosphorus and sulfur are 2 non-metals, so this has to be a covalent compound. The first element, P, stands for phosphorus. The second element's name with IDE. Now S stands for sulfur. Sulfur's IDE name would be sulfide. Then we have to use prefixes. So we have 4 phosphorus atoms, and we use the prefix tetra for 4. So we add tetra. We have 10 sulfur atoms, so we're going to use deca. And sometimes deca is also written as DECA. Yeah, there it is. So we'll add DECA. Tetra phosphorus deca sulfide. Easy. Now let's discuss a few rules. So the first rule which we'll discuss is this one. The prefix mono is never used for the first element. So by that we mean, let's learn this rule through an example. So pH3, first we identify whether the compound is covalent or ionic. Phosphorus and hydrogen are both non-metals, and because they're non-metals, pH3 has to be a covalent compound. Then we identify the first element in the compound. P stands for phosphorus, so we write phosphorus. Then we identify the second element, and we write its name with IDE. So hydrogen, so its IDE name would be hydride. So we get hydride. Now we use the prefixes for step 4, and we just learned that 1 stands for mono, 2 stands for di, 3 stands for tri, and so on. And there's only 1 phosphorus atom in pH3, so it's only logical to think that we'll use mono, and the name of this compound will be monophosphorus trihydride, but that's not the case. And so the thing is, we use tri for hydrogen. We have 3 hydrogen atoms, so we use tri here, TRI, and we don't insert mono here. Instead of writing monophosphorus trihydride, we just leave it as phosphorus trihydride. So we never use mono for the first element. Another example of this is CCl4. So this is a covalent compound because chlorine and carbon are both non-metals. The first element is carbon, so we write that, carbon. Second element is chlorine. We have to write its IDE name, so this would be chloride. There are 4 atoms of chlorine, so the prefix we'll attach here would be tetra, TETRA. There's only 1 atom of carbon, but because carbon is the first element in this compound, we do not use mono. We just leave it as carbon tetrachloride. So an example of when we do use this prefix mono is of CO. Carbon and oxygen both are non-metals. Because they're non-metals, this compound has to be covalent. So I'm going to write carbon here. Then we write the second element's name with IDE. Oxygen becomes oxide. Now we have one carbon atom, but we don't use mono for the first carbon atom, so we leave this as it is. We have one oxygen atom, and we do use mono for the second element. So this would become carbon monoxide. Now we can see that we have two O's right here. And sometimes it gets pretty awkward to pronounce these chemical names. So when we have two O's, or we have one O and one A, then these turn into a single O. Yeah, both turn into a single O. So carbon monoxide becomes carbon monoxide. We replace the two O's with a single O. So that was rule number 1. The second rule we touched upon briefly above, and this one says we replace AO and OO with O. So this is much easier to demonstrate. And so this rule means, first we try to name this compound. So this is a covalent compound because chlorine and oxygen are nonmetals. The first element is chlorine. The second element is oxygen, and we write this with IDE. So this becomes oxide. We have two chlorine atoms, so we use the prefix di. We get dichlorine. We have 7 oxygen atoms, so we use the prefix hepta. Now we have A and O together here, and we replace this by O according to this rule. So the name of this compound becomes dichlorine hept, and then we just write oxide. We replace the A and O with a single O. Next is carbon monoxide. This is a covalent compound. We write the first element's name, then we write the second element's name with IDE. Only one atom of carbon, but we don't use mono. One oxygen atom, so we use mono here for oxygen. But we get two O's, so we replace this by a single O, and we write carbon monoxide. We replace the double O with a single O. Next is phosphorus, P4O10. This is a covalent compound. We write the name for the first element. So we write phosphorus. Here we write oxide. We have 4 atoms of phosphorus, so we use the prefix tetra. We have 10 atoms of oxygen, so we use DECA or DEKA. We then get A and O together, so we replace this by single O, and we get, so the actual name of this compound is tetra phosphorus deoxide. So this was rule number 2. We'll now name a few covalent compounds, which are some examples. So P4S10, first element is phosphorus. So all of these are covalent compounds. We already know that because all of these contain nonmetals. So here the first element is phosphorus. So we write phosphorus. Second element is sulfur. We write that with IDE. So we write sulfide. We have 4 phosphorus atoms. Wait, I'll just copy paste the table here. We have 4 phosphorus atoms. Yeah. We have 4 phosphorus atoms, so we use the prefix tetra. 10 sulfur atoms, so we use the prefix deca. Next is S4N4. S stands for sulfur, so our first element is sulfur. Second element nitrogen, we write that with IDE, so nitride. Nitrogen becomes nitride. 4 of each, so we use the prefix tetra for both. So the name of this compound is tetrasulfur tetranitride. PCl3. P stands for phosphorus. Cl stands for chlorine, and we write this with IDE. So we get chloride. Only one atom of phosphorus, but we don't use mono for the first atom, for the first element. 3 atoms of chlorine, so we use the prefix tri. So the name of this compound is phosphorus trichloride. SbCl5. Sb stands for antimony. Cl stands for chlorine. We write this with IDE. So chlorine becomes chloride. Only one atom of antimony, but we don't use mono for the first element. So we leave this as antimony. We have 5 atoms of fluorine, so we use the prefix penta. So the name of this compound is antimony pentachloride. CO. We just named this compound. This is carbon. Then we have oxygen. 1 atom of carbon, we don't use mono for the first atom. 1 atom of oxygen, we use mono. But when we have 2 O's together, we remove one of the O's. So the name of this compound is carbon monoxide. NO, first element nitrogen, second element oxygen. We write this with IDE. 1 atom of nitrogen, but we don't use mono. 1 atom of oxygen, we do use mono, but we have 2 O's, so we replace this with 1 O. So we get nitrogen monoxide. Next is So2, sulfur dioxide. First element's name is sulfur, second one is oxygen. With IDE, this becomes oxide. 1 atom of sulfur, we don't use mono because sulfur is the first element. 2 atoms of oxygen, so we use the prefix Di, sulfur dioxide. Let's do BrCl. Br stands for bromine. Cl stands for chlorine. 1 atom of bromine, but we don't use mono for the first element. 1 atom of chlorine, we do use mono for this. So we get bromine monochloride. This is chloride, IDE. Let's do this one, I4O9. These are pretty simple. So let's do I4O9. I stands for iodine. O stands for oxygen. We write this with IDE. 4 corresponds with tetra. O9. 9 corresponds with nona. Nona. But we get ANO together, so we eliminate A, and the name of this compound becomes tetraiodine non-oxide. Let's do this one. XeO4. Xe stands for xenon. Xenon is a noble gas. O stands for oxygen. One atom of xenon, but we don't use mono for the first element. 4 atoms of oxygen, we do use mono for every other element. Sorry, 4 atoms. 4 corresponds with tetra. But again, we have ANO together. So to avoid awkward pronunciation, we replace A and O with a single O. So we get xenon tetroxide. This is wrong. So the name of this compound would be xenon tetroxide. This would be nitrogen trifluoride, this would be phosphorus pentaiodide, dichlorine heptoxide, sulfur trioxide, carbon dioxide. So these do become pretty simple after you practice a lot. I'll attach a link in the description to a website called Chemistry Quizzes, where they have, I think, around 15 or 20 quizzes on different topics, and one of those topics is naming compounds. And I used this website to practice. I still use it. So use karna to kar lena. So I'll attach a link in the description. Thank you for watching. Yes, that's it.